Myself, Dr. Prashant Kumar Bartu, Professor, Department of Mechanical Engineering, JIS College of Engineering, Kolani. My subject topics is Advanced Welding Technology, ME 703A. Today is the lecture number 15, Friction Stir Welding. Friction stir welding is one of the solid state welding. Friction stir welding. Friction stir welding is a solid state joining process that uses frictional heat generated by a rotating tool to join materials. The non-consumable tool with a center probe is rotated and inserted into the interface between two workpieces before traversing along the weld line. Today's content is in this lecture is introduction, principles of friction stir welding, friction stir welding setup, materials used, stress and graph, comparisons, advantages, disadvantages, applications, future developments, and conclusions. Introduction. Friction stir welding was invented by Wayne Thomas at TWI, the Welding Institute, a British Institute Limited in 1991. It overcomes many of the problems associated with conventional joining techniques. Friction stir welding is low energy input, capable of producing high strength weld in wide range of materials at lower cost. Friction stir welding process takes place in the solid phase below the melting points of the materials to be joined. Welding. Welding is a joining process by application of heat, with or without application of pressure, and filler materials or electrodes, making a permanent joints. The classification of welding, the two main classifications are fusion welding, heated to molten state, and no pressure required, that is gas welding, arc welding, etc. Another is plastic welding, where pressure is required, heated to plastic state, and that is, example is friction welding, friction stir welding, forge welding, ultrasonic welding, etc. The different type of friction welding processes. One is linear friction welding. Figure shows that linear friction welding. This is linear friction welding. Rotary friction welding. This is rotary friction welding. Conventional welding. Friction welding is this. And friction stir welding is this figure is friction stir welding. Radial friction. This is radial friction welding, and this is orbiting welding. This is orbiting welding. So today we will discuss about the friction stir welding. Friction stir welding is a relatively new solid state joining technique which is widely adopted in different industry fields to join different metallic alloys that are hard to weld by conventional fusion welding. Friction stir welding is a highly complex process comprising several highly coupled physical phenomena. Friction stir welding, this is a figure how it works. This is this shoulder, and this is rotating, two rotates, and this is spin. This is a welding direction, downward force is there. This is spin, and this is welding nuggets, advancing side, and retreating side, welding region, friction stir welding region. This is the region. So this is a friction stir welding process. how it works. Working principle of friction stir welding. Friction stir welding, a cylindrical solder tool with a profiled probe is rotated and slowly punch into the joint line between the two pieces butted together. Friction heat is generated between the wear resistant welding. This is the process sufficient downward force to maintain resistor contact. This is the friction where rotating side. This is advancing side. This is shoulder. This is joint, leading edge of the rotating tool, trailing edge of the rotating tool. This is the working principle. Working principle of friction stir welding. Basic concept of friction stir welding is remarkably simple. A non-consumable rotating tool with a specially designed pin and solder is inserted into the abutting edges of sheet or plates to be joined and traverse along the line of joints. Figure I have shown you. Figure 1. The tool serves two primary functions, that is heating the workpiece, and B is movement of the material to produce the joint. Friction stir welding. The heating is accomplished by friction between the tool and the workpiece and plastic deformation of workpiece. Plasticized material is transferred the front edge of the tool to back edge of the tool probe, and it is forged by the intimate contact of the tool shoulder and pin profile. This is the experimental setup of friction stir welding. This is like shows like a milling machine, vertical milling machine, where it can be done with some accessories is there. And in this welding, some inert gases are there. These sealing gases are there, which is maybe nitrogen tank. This is nitrogen tank. This is motor 3 HP. So this is exhaust hose. So this is the setup, friction stir welding setup. It can be done in the vertical milling machine. Some rotation of depends upon the material and the pressure to be given. Welding steel using friction stir welding. This is a rotating tool. This is a probe, and there is a probe where the welding is carried out. This is welding. After this welding is done, this is the probe, how it is working. And after this welding is done, and finishing welding portion by friction stir welding. How finishing is very good and with no effect of heat affected zone. Less heat affected zone. Important welding zones. Friction stir welding in its cross section consists of three main zones: nugget, steel zone, thermomechanically affected zone, and heat affected zone. The three zones pose distinct mechanical properties, and nugget and thermomechanical affected zone being the weakest part of the joint. This is a microstructure analysis. This is A is unaffected zone. It's a material. A is unaffected material. B is the heat affected zone. Just see how less is there. And thermomechanically, C is the thermomechanical affected zone. This is the thermomechanical affected zone. This C, and B is a heat affected zone, and A is the unaffected material. This is the width of the tool shoulder. You see how the D is the basically the weld nugget, part of thermomechanical affected zone. This is the microstructure analysis of the friction stir welding. Important welding parameters, tool design. The design of tool is a critical factor, as a good tool can improve the quality and welding speeds. Tool is strong, tough, hard wearing at welding temperatures. Have good oxidation resistance and thermal conductivity. A13 steel has proven perfectly acceptable for welding aluminum alloy, but more advanced tools are necessary for more high demanding applications. Tool rotation and speed. The two tool speeds are considered in friction stir welding, how fast the tool rotates and how quickly it travels along the interface. It can be said that increasing the tool rotation speed and decreasing the traveling speed will result in a hotter weld. In order to produce a successful weld, it is necessary that the material surrounding the tool is hot enough to enable the extensive plastic flow required and minimize the forces acting on the tool. If the material is too cold, then voids or other flaws may be present in the state zone. This competing demand lead into the concept of a processing window. Processing window is basically the range of processing parameters that will produce a good quality weld. Within this window, the resulting weld will have a sufficiently high heat input to ensure adequate material plasticity, but not so high that weld properties are deteriorated. So, processing window is basically the is required for processing parameters that will produce a good quality weld. Macrostructures, just see the A, B, C. This is the defects, and this is defects and voids there due to previously we told that due to cold welding, sometimes if it is too cold, maybe some void is created. This is the thermomechanical affected zone, and this is has zone. So these are microstructure. This is a microscope, optical micrograph of region A, B, C. Just A is the mid portion. This is the B portion. B is the this portion. It's a good portion, and C is the this nugget portion. This is A is nugget, and B, C is sidewise. So steel nugget. This full nugget, A is central, A is this microstructure, B is sidewise. This microstructure better than this A, and these are the pulse defects. Joint geometries, it can be used in all positions, horizontal, vertical, overhead, orbital. These are the joints. How good is it is. So horizontal, vertical, overhead, orbital, all the positions can be joined by steel welding, friction stir welding. Material suitability, copper and its alloy, lead, titanium and its alloy, magnesium alloy, zinc, plastics, mild steel, stainless steel, nickel alloys. Tool parameters, H13 steel tool are used. Tool is strong, tough, and hard wearing at welding temperatures, have a good oxidation resistance, thermal conductivity. This is a section, diameter is 1.2, this is in inches. This is in inches, 2.78 length, inches. This is portion is pin tool extension, that is 0.4. 0.05 0.05 inches, and this is pin diameter is 0.34 magnified cross section. So the pin. So these are the figure of the tool. This is the tool probe. This is the tool. Common tools. There are various common tools are there. This is common tools. Self-reacting pin tool, fixed pin tool, adjustable pin tools, and the retractable pin tool removable type. So these are the tool retractable pin or removable type. So 4 type of tools are here. Other varieties of tools are there, definitely. So some of the friction steel welding machine made by ISAB India Limited, ISAB Limited, ISAB supplier steel TM machine, FW28. This is also a ISAB machine, friction steel welding machine. Stress strain graph, and this is stress and this is strain NPA, and this is the tensile. This is the tensile stress UTM, the figure, and rate tracer friction after the. This is standard, and this is the welding, friction steel welding. The figure is this. So it is very much parallel. Good strength is there, so it can be considered a good strength. The friction steel welding. Comparison with other joining process, friction steel welding versus fusion welding. Good mechanical properties by weld at below melting point of workpiece. Reduce distortion, reduce defect rate, better metal chemistry, simplify dissimilar alloy welding, eliminates consumes, reduce health hazards and no weld pool. Sometimes it is called the green welding. Friction steel welding is green welding. So advantages, good mechanical properties as in weld condition, improved safety due to absence of toxic fumes, no consumables, easily automated on simple milling machines, can operate in all positions, vertical, horizontal, etc. Low environment impact, high superior weld strength. Disadvantage, workpieces must be rigidly damped, slower traverse rate than fusion welding application, aerospace, shipbuilding and offshore, automotive, fabrications, railways. Future development, laser assisted friction steel welding, possible use of induction coil and other mechanism. Conclusion, friction steel welding opening up new area of welding technique. No distortion, scattered fumes, welding at below melting point of workpiece, good forging action by tools, create high strength weld in hard materials. It is alternative to fusion welding. These are the reference. Jayaraman, Shiva Subramaniam, and Balakrishnan. Bala Subramaniam, optimization of process parameters of friction steel welding of cast aluminum alloy A319 by Taguchi method. This Hema, Gangadhar, and Rabindranath, optimization process of parameters of friction steel welding of aluminum alloy 60161 using ANOVA, the International Journal of Mechanical and Production Engineers, 2012, and Doval, Berati, and Johaji, process optimization and mechanical properties of friction steel welding, lab welds of 7075 T6 Stinger num 2024 T3 scheme, Jana materials and mechanical. So I have completed today's lecture. Now, thank you to all of you.